This system was used in Britain and Australia before the adoption by the International Standards Organisation of third-angle projection. The model I've got here is the model that we used before to describe third-angle projection system, and we're going to use the same front elevation. Front elevation, as I said, is exactly as it was before. A view from the left-hand side, which we're showing here, is actually projected right over onto the right-hand side in first angle projection. It's the same with all the other views. Here we've got the front elevation again. A view from the right-hand side is projected over here onto the left. A view from the top is shown below the front elevation, and a view from the bottom is shown above the front elevation. All the views are identical in format, in shape, to the views used in the third angle projection system, but they're just in the opposite positions on the sheet. The symbol for this again is based on the truncated cone. We'll have that way around. If we look at from the small diameter end, so we can get the two concentric circles, that's shown over here on the left hand side. So a view from the right of that is shown over on the left hand side. This means that the two concentric circles are going to be next to the larger diameter of the truncated cone. And it is the same if we show the symbol the opposite way up. If we had drawn the truncated cone originally in that position, then the two concentric circles would then be over on the right hand side. And we've got that shown here on the title block in this symbol here, in this corner of the title block. So again, we've got the truncated cone, front elevation. We project from the left hand side so we can see the two concentric circles, and it's shown over onto. This is the model used in Boundy. I'd just like to show you the object to start with, the front and top. Okay, this is the side that's been chosen by Boundy as the front elevation, the front view. As you can see how it lines up there. The front view on its own is not sufficient to manufacture the item from, because it doesn't show any details in the third dimension. For instance, it doesn't show that face is actually further back than this face. It could be, from looking at that, it could be the other way around. That face could be in front of it. So we need to show some other views. Here we show a view of the left-hand side of the model. If I rotate the model around, you can see that's what is seen from the left. So the left view is shown on the left. I've projected, all I had to do to construct this left view was, first of all, I projected all the heights across from the front elevation, and I measured off the width. So all I had to measure was the width on that particular object. Here we've got the right view, which is just a case of rotating this towards the right, and you can see the right view of the model and the right view on the drawing. So the right side of the model is shown on the right. Very infrequently we may need to show the rear view of the model. So that is taken in this particular case from rotating from the right view. It just looks like an L shape. Similarly, a top view is shown above the front elevation just by rotating the object through like that. You can see that I've projected the widths from the front elevation up onto the top view. So all I had to measure was the vertical dimensions. A view of the bottom, which doesn't give a lot of detail, is shown below. It's just a case of rotating the model through like that. It's just a straight rectangle. There are in fact 3 views are all that's actually required to fully depict this object so that it can be manufactured. I've got the front elevation. I've shown the view from the left-hand side in this particular case because it shows a little bit more detail than a view from the right-hand side. I've also shown the top view because it shows this detail. If you remember, the bottom view was just a pure rectangle. If that was dimensioned, that would be adequate for the component to be manufactured. As I mentioned before, all the heights from the front elevation are projected across onto the side view, so I only had to measure the width. All the widths of the front elevation were projected up to the top view, so I only had to measure the vertical dimensions. But we can also set up a projectioning system. That means that the dimensions measured in the vertical direction on the plan view can be transferred straight onto the side view, or vice versa, so we only have to do that measurements once. To set the projection system up, we project across from the 2 outside dimensions of the top view horizontally, the 2 outside dimensions of the side view vertically. Where they intersect, we draw a 45-degree line through. That's the setup for the projection system. Any other details we need to transfer from one view to the next, we just transfer along, hit the 45-degree line and drop down, or vice versa. In this particular case, we've only got one piece of detail, so it hardly seems worth setting the projection system up. But in most technical drawings, there will be a host of detail that we'd want to transfer across. I mentioned before about setting up about the choice of front elevation. The front elevation boundary chose was that view. If we'd have chosen this view instead, as the side view, we would end up with a very tall plan view, and this gives a lot of restriction in this space here. To get that all onto the page, pages tend to be fairly horizontal in layout. They're longer than they're tall. We've got a restriction here. It makes it difficult to insert much in the way of dimensioning into that space. Finally, the projectioning symbol is based on a truncated cone. We accept that as a front elevation looking in that direction. The end elevation is always chosen, so we end up with 2 concentric circles. Okay, we've got the front elevation there. We rotate that round to have 2 concentric circles. The 2 concentric circles are shown near to the narrow end of the truncated cone. The same symbol could be shown the other way up. So the truncated cone could be shown with the narrow end to the left, in which case we've got the 2 concentric circles shown on the left-hand side. It's shown in the title block in that position. That depicts that we've got a third angle projection drawing.